Okay, I submitted your Scantron sheets into testing services this morning, and I should be getting the results emailed to me any moment. So I didn't see them before I left the class, but they could come in now or in an hour, and then I will crunch the numbers, and I will post raw scores and then an announcement. Look for an announcement on Blackboard with everything about the results and the scoring. Okay. But let's press on here. So today we're going to continue with our conversation about differentials and linear functions, but we're going to work pretty intensely in graphing calculator. So if you do not have graphing calculator on your laptop, find someone who's willing to share so you can get close, look over their shoulder, work together, okay? Looks like reduced attendance today. Okay, first though, let's talk about a refined meaning for dx. A refined meaning for dx. So far we've said, are there any announcements I should mention?
Do we collect the homework again?
No, we're not collecting it, right?
We're not collecting it.
Just to tell them? Okay, yeah, I emailed it. Yeah. So yeah, the short homework was mostly preparation for the exam. We won't collect that, okay? So the short written homework, that was a repeat of Wednesdays. We're not going to collect that. That was just for you to have a little more study practice. Okay. Any questions before we start? Okay, so we've talked about dx as what? We've said that dx is simply a change in x, right? We said it is a change in x. So we want to just refine that a little bit. Yes, I am. Now we will qualify that to say that dx is a little change in x. So we want to say it's a small change in x. What do we mean by small? We'll talk about that. But instead of just being any change in x, that's how we've considered it so far. So now we want to say it's a little change in x. And then we're going to have a name for it, which I actually put on your review sheet. And so I thought that was part of the Chapter 3 language, but it's not. Sorry about that. This is the Chapter 4 language. Dx is the differential in x. Okay? So we'll call it the differential in x, and that's going to mean a little change in x. Okay, so one more note on that. If you have related variables y and x, and you're talking about the differentials dx and dy, talking about differentials dx and dy necessarily implies constant rate of change. Okay? If you're talking about how x and y vary together, and you're talking about dx and dy, that means you're talking about constant rate of change, and these are little changes in dx and dy. Okay, and otherwise dy must be a constant multiple of dx. Okay, dy must be a constant multiple of dx, like we've been talking about. Dy equals m dx. Yes, I am recording. Okay, I am recording. Yes, I am. So, all right. Okay, so questions on that. So dx is now we're going to call it the differential. It's going to be a little change in x. And in the context of talking about dy and dx together, that's going to always mean constant rate of change. Okay, so once you get out GC, open up a new command or a new file window. We use steps to recreate this graph, which represents the relationship of time, okay? Time in days after a sunflower seed germinates, and the height of the sunflower in centimeters. Okay? So you got a couple of just warm-up questions here. And then you're going to go through each step one at a time, and our goal is to produce a display graph that looks just like this, okay, showing that as time goes by, the height of the sunflower grows according to these correspondence points. And so I would just say, just go. Let's see how we do on A through F. A through F. We'll come around and help you, but our goal is in 5 or 10 minutes to have this graph because you understand. Okay, let's talk. So it's been a while. It's been a while with this, and so we want to review and make sure we got this. The first thing is defining the function. First thing is getting, please, there, okay. So item C, define the function, and at this point we don't need to specify the domain because we're not displaying anything. So we can just put that function definition in, and I think I hope I have it right there. Yep, okay, got it right. So questions about defining the function. Remember, you need Control 9, not Shift 9, or else it thinks it's multiplication, right? If you use Control 9, then it knows you're talking about function notation. Function notation. Okay, so then why doesn't it graph it? Why doesn't it graph it? Because what tells GC to graph? X and Y, X and Y. So we got to come in here and we have to, item E says, graph it. I have it to 11, that's your 10. Okay, so here's item E. We want on the y-axis to represent the dependent variable. And the dependent variable is our function notation. And we want that for every x. So we're going to do y equals h of x. That should make perfect sense. There's no need to type in that formula again. We've already defined h of x as having that rule. So now we or h of t. So now we just do y equals h of x. And here is where you're going to tell it, okay, I only want you to plot the points for this domain, 0 to 10. And then you should get it. And then you have to, so if you are, you can adjust, zoom just on the, just on the y-axis by hitting Command on Apple, or is it Shift or Control on Control? So Control on a PC or Command on Apple gives you just the ability to zoom in or out on the y-axis in those little icons down there. And then if you hit Option on Mac or Shift on PC, then you get the ability just to zoom in and out on the x-axis. Everyone able to do that? And so then you can get this particular arrangement that I have here, these scales on the axes, and this nice view of the display graph. Questions on anything so far? Okay, cool. So I don't think we've covered points yet, so I guess F was kind of an impossible task for you. Here's how you plot a point. So I'll just start over. In the command line, you're going to hold down Control and hit 2. And that's going to open up these brackets with two variables x and y. So this is now telling Graphing Calculator to display a single point. Display a single point. And so we want, which one? We want the correspondence point for t equals 5.2 days. And we want to use an exact representation for the value of height or dependent variable. So what is my x coordinate requested here? Oh no, sorry. It should be 1.8. I changed it. I got most of the changes, not that one. Sorry. This should be 1.8. Okay? So now, what should my x coordinate be? 1.8. And now I want to have the correspondence point. So what's the corresponding height or value of the dependent variable? Exactly. Exactly. How can I represent exactly what that dependent variable is? Is that a hand? H of 1.8. See, this is the beauty of function notation. I've already defined the function h. I don't have to punch in 1.8 and get the number. I can just use my function using function notation. So I'm going to do Shift, H, and then Control 1.8, and what is that? That's the value of the dependent variable when the independent variable is 1.8, or the height of the sunflower after 1.8 days. And that's exactly what I want for the y coordinate. And so it should appear. It should appear now as that dot highlighting the point on the curve that was already there. 1.8 comma h of 1.8. Questions? Are we good so far? Are we good? Okay, yeah. All right. I'll be. And you got to make sure you use Control 9. Every time you're typing in function notation, do Control 9. Sometimes it anticipates. It knows that's what you want if you do Shift 9, but just don't take any chances. Just every time you're doing function notation, do Control 9. Okay, let's go on to the next slide and see how we do. Okay, did we talk about defining a character string? So using a letter string to mean a parameter, so a string of like several letters together to mean either parameter or variable. Did we talk about doing that? Well, anyway, so the way you do that is you open up a new command line. We're going to call it DT. And so you're going to hit backslash, which is above the return key, backslash. Then you're going to type in your string of letters that are together you want to be a single parameter or variable. So we want DT, and then hit backslash again. And when you hit backslash again, I've already done it, but when you hit backslash again, then the backslash should disappear. And now that string of characters, in this case DT, is a single parameter, single variable. Did it work? So it should look like that when all is said and done. And then we want to set that to 0.15 days. Because now we're talking about the differential being a little change in our variable. Did it work? Are you able to get dt as a single variable, set it equal to 0.15? Okay. If not, we'll come around and help you. So now you have, if you look here, you see that there's something else going on here. So I'm going to come down here, and I'm going to zoom in. If you put the crosshairs, click on the curve close to your highlighted point there, and then just hit zoom in. Don't do just zoom in, and you see that there's something else that I have in my visual, and that's what you'll do next. So this is to see. So there's that point, 1.8 and h of 1.8, the corresponding point for 1.8 days. Okay, but then there's these two segments, and so we want to mathematically tell GC to graph these two segments. And so the first one is a segment showing a change t of 0.15. Beginning at 1.8. Okay? And then the second is the corresponding change in height of the sunflower as a vertical segment. Okay? So you aced these questions on the test last night, this should be no problem, right? So there's kind of questions like this on the exam. All right, so here we go. Here's item 8. Questions? Is it working? What y value will that be? Did you get it? Good. Okay, let's regroup. So you got to have the mentality of if I want GC to display something, it's going to be a set of points. How do I mathematically define that set of points? That's the mindset you have to have. How do I mathematically define the set of points that is this horizontal segment? Okay, so if you're still working, that's great. Just whisper. That's fine. Just don't use your loud voice. Just whisper, okay? So you got to get in the mindset of how do you mathematically define that set of points? So if you mathematically define it correctly and precisely, GC will display it. So what's true about all those points? All those points have the same y value, and that y value is h of 1.8, right? It's the dependent variable when the independent's 1.8. Okay? So that's why we say y equals h of 1.8. Now we have to say for what x values, or all the x values are different, but they start at x equals 1.8 and they end at dt later, right? dt greater than 1.8. So we could put in 1.95, but this is going to be better so that if we want to change dt, then this command line doesn't have to be changed. It'll just automatically give us a different line segment for varying dt. Okay? So what about this? What's true about all the points on this line? It's true about all the points on that line. The x is what? Okay, but instead of 1.95, 1.8 plus dt, that final, so it's the same as that final value of x for the horizontal segment, is going to be all the x values on this vertical segment. And that's going to be, now y is restricted between what and what? The lowest value of y is h of 1.8, and the highest value of h is the actual function value or dependent variable at this x value, which will be h of 1.8 plus dt. So questions on these two? Doesn't make sense. Any questions before we go on? So now I'm asking you to estimate the constant rate of change for this change in time. So for this change in time, we're going to estimate the constant rate of change, which is a calculation. If you haven't done it yet, go for it. So so here's to do that. Then we're going to use if you double click on say this curve, the red curve, you get the crosshairs. You can move the crosshairs. And it should knock at intersection points. You're hearing like a knock. But anyway, I'm not hearing it. But anyway, and then you get real small up here. See that right there in your screen? You should get the corresponding coordinates. So what is h of 1.8 plus dt? Let's use 4.55. Use 4.55. And what is h of 1.8? So if we're actually going to estimate this, we need the numbers now. So come down here. H of 1.8, 3.84. So if we're going to estimate that constant rate of change, we need these numbers now. So this was 1.95. What did I say? 4.55. And 1.8, 3.84. So we have a dt. We know the dt is 0.15. What is our estimate for the constant rate of change over this interval? What's the estimate for the constant rate of change? Can you find it? You should be able to. No problem. Anybody got it? Use graphing calculator, okay? You've got a calculator right in front of you. Don't get out your handheld. Just do it on the next command line. It does, remember, it does normal calculations too. So how will we get it? You should have done that. What? Yeah, and then, I defined m using that formula, and then I go on to the next line, just type m, and it tells me what it is. Okay? So I defined m using the formula. Next line, just type m, and it tells me the current value, which is what we defined it as. What's that? Okay, so now we're going to use that constant rate to estimate some values of height. So given this starting point of 1.8 and h of 1.8, which is 3.84. Okay, last chance. I'm gonna erase and go on to the next screen. So any questions on this stuff? Last chance. Here we go. So the next thing we're going to do, we'll do this together. Item K. We're going to make dt a slider so it's truly a variable that we control. Okay? Ready? Hit dt equals, type out the word slider. And when you finish, it should just pop and look like that. Hit Shift 9 for parentheses. Starting value of our variable dt is 0. Final value is 0.15. So 0, comma 0.15. So we're going to look at changes between 0 and 0.5, and we'll do 30 steps. So then comma 30 tells it to change dt in 30 steps from 0 to 0.15, or 30 increments. But in order for that slider to work, we have to come back up to where we define dt and just get rid of the, so right now it's set at 0.15, the slider's not going to work. So, because it's kind of conflicting. These two command lines are trying to set dt at different values. So just erase the part where you said it equaled something. And just leave it there, dt. And so now it's showing me that according to my slider, right now the value of dt is 0. It's no longer 0.15. And so then I can come along here. And since you defined those segments in terms of dt, look what happens. Because you define those segments in terms of dt, now dt is a variable, and you get the corresponding segments for the given value of dt. Is it working? Okay, so we want to set the slider to 0.03. So grab it and set it to 0.03. And now I want you to, based on constant rate of change, predict what is the height right there of, so you're going to, we're on L now. Use changes to estimate the corresponding new height of the sunflower. So we're going to estimate what the height is. Using our principles of constant rate of change. Can you do it? Can you do it? What is the height? So starting at 1.8, we're saying that there's a change, a little change of time of 0.03 days. What's the new height? What's the new height? Can you do it using constant rate of change? Take a minute. See if you can. So you should be able to. So we've got the old height here, 3.84. Time changes by 0.03. We've got the constant rate of change of 4.7. Use all that information to find the new height, and do it on GC. Your next command line will be item L, will be a command line that predicts that new height using these changes and using the constant rate. So now dt is 0.03. Okay, volunteer, who thinks they know how to set it up to predict that new height with all the stuff, changes, constant rate of change that we're using? How can we predict that new height? I see a hand right here. Tell me. H of 1.8. Okay, so that's so you're just using the function to do it. So that's the exact value. We want to estimate it using the constant rate of change principles. So it's not wrong. That's actually exactly what it will be. But now we want to use this idea of the changes and a constant rate to estimate it. Yes, sir?
1.8 plus t times L.
Okay. And what does that equal to? So 1.8 plus dt is?
Yeah, plus dt, so you have to x value.
Okay.
And then multiply that by this constant rate.
But then you want to add that to 1.8, because dt times m will give you what? The change in?
Yeah, 1.8 plus dt, and then times.
Okay, that's not quite right. Not quite right. Yes, sir?
dt times m, and then you add that 1.8. Or sorry, you add that 3.84.
Okay, there we go. That's what it is. You're going to do, so we have the change in t. We need the change in height. dh. What's the change in height given that change in time? Okay, we spent all day Wednesday on it. M dt, right? If we have constant rate of change. So it's going to be our m times our current dt and that will be dh. And so then the new h will equal the old h, 3.84. This is what he said, plus the change in h, or dh, plus our little dh, which will be the m dt. So let's see it. Here it is. So I could have put dt in there. So m, because it's set at 3, so m dt gives us the change in h, right? If constant rate of change, then changes in the dependent are m times changes in the independent, plus the current value of h equals 3.982. Okay, anybody have a question? There was a little bit more, but we'll just stop there. Question, yes?
I did m dt plus h of 1.8, and it got a little bit different number.
Okay, but that's two different units. H of 1.8 is a height. dt is a change in time. So it wouldn't make sense to add dt to an h value. So you almost have it. Yeah, h of 1.8, that's 3.84. You want it plus m times dt. The change in height, not the change in time, change in height.